Hey guys, Zulk here, back on my bullshit. Before I continue with this episode, like always, I have to say the disclaimer. If you clicked on this video because you needed to learn C++ for whatever, this is not the video for you. This is not a good tutorial on how to learn C++. You might be able to learn C++ by watching this series, but it's not going to be fast. It's not going to be efficient. It's not going to be good. This is more so me recording my own struggles, trying to teach myself how to learn C++. So, if you want to see that, by all means, continue to watch the video and like the videos in the series. But if you're just here because you need to learn C++, I highly recommend you click off right now and find a better C++ tutorial. And I hope that whatever it is you need C++ for, it goes well for you. So good luck with that. Anyway, everyone else that remains, welcome back. So for a bunch of different reasons, I was not able to record for like a month, 2 weeks or something. This is true for both my main channel and this channel. I already talked about it on my main channel when I started recording again. And this is the second channel video after that. So yeah, I am realizing something horrible about the second channel. Well, not the channel itself, but this series. Is that I am going way too fucking slow in my learning process of C++. Like, I have this huge book here. If I read like 2 pages of video and make like 3 videos a day or a week or something, I am never gonna learn C++. So here's what I'm gonna do. Unless absolutely necessary, I am gonna skip all the exercises that I've been doing, and I'm just gonna read the book and try to, I don't know, vocalize whatever it is that I think I'm learning from it. Maybe do 1 or 2 of my own experiments, which is why I have code blocks open, just to see how things work, instead of trying to follow the book exercises, unless absolutely necessary. And by doing that, I intend to speed run through the C++ learning process. Less effective, I'll get a lot less practice, but hopefully I'll be able to grasp the concepts quicker, and even if it's not that effective. And you may be thinking, if you've studied code, which I have, not C++, I have learned Python and a bit of HTML and CSS as well. So if you have learned any programming language, you would know that this is usually not a good idea, because like, if you don't practice a programming language for long, you will forget stuff. At least that's my own experience. Like, I learned HTML and C++ a long time ago, and I had to relearn it again last year because I just did not do anything with HTML and CSS for the longest time, and I forgot how everything worked in that one. So I had to reteach myself that last year, and right now I know how to do HTML and CSS. But yeah, that's my point. So you may be thinking, how is this gonna work? Like, if I'm not practicing C++, I'll just forget everything I read. I have an idea. I have a solution to that. See, this is not the best way to do this, I'm pretty sure, but this is the fastest way that I think I can do it. See, the reason I want to learn C++ is because I really want to make my own games, and I want to make some games in, I think, Godot or Unreal or Unity. Well, I wanted to say Unity, but after the whole debacle that happened last year, I'm not sure if I want to use Unity anymore. But whatever, I want to make my own games. For that, I need C++. And here's where I want to get my practice in. I'm going to read the basics, and when I'm done reading the basics, reading this book, I am actually going to move on to the second series on this channel, which is, while it is a second series, it is technically the spiritual successor or the continuation of this one, where I'm not just trying to mess around and find out how to do stuff in C++, but I'm actually trying to use what I have read from this book to make my own game. I have a few ideas on what kind of game I want to make. Nothing too complicated, start off simple, but before I can do any of that, I need to read this book. So I'm going to read this. I'm not going to read it aloud, and maybe I should read it aloud. I don't know. I'll read one or two lines which I think is important aloud, but most of the time I'm just going to read silently. Okay? Okay. So this section is some difference between C and C++. Oh, by the way, in case you want to know what book I'm reading, it's called Teach Yourself C++ by Herbert Schlitt. So, yeah. If you think that you can learn C++ better uh, by, I don't know, reading this book yourself, I recommend you go buy this book or something and read it that way. Buy it or borrow it from the library. I'm sure this book is in libraries, right? Yeah, borrow it from a library or something, your nearby library, and read it yourself. I feel like that is going to help you learn C++ way faster than watching this series ever will. And potentially watching a much better YouTube tutorial is going to speed that up even further. Anyway, enough lollygagging. Let's continue. This section is called Some Differences Between C and C++. Although C++ is a superset of C, there are some small differences between the two, and a few are worth knowing from the start. In C, when a function takes no parameters, its prototype has the word void inside its function parameter list. This is true. For example, in C, if a function called f1 takes no parameters and returns a character, its prototype will look like this, char f1 void, yes. However, in C++, the void is optional. Therefore, in C++, the prototype for f1 is usually written like char f1 with brackets it's encircling a blank. Okay. If the preceding prototype had occurred in a C program, it would simply mean that nothing is said about the parameters to the function. In C++, it means that the function has no parameters. Okay. The use of void to declare an empty parameter list is not illegal. It is just redundant. So in C++, char f1 and brackets with nothing inside it is the same as char f1 brackets with void inside it. Let's see. Let's test it out for real. So let's create a function, shall we? Going back a bit to the previous thingy. Hold on. That's the class section. Oh, they did not actually go in depth about functions. I forgot about that. I guess they just assumed people would know how to write functions, which is true because I do know how to write functions. I was just a bit confused, I guess. Anyway, going back here, let's make a very basic class. Where's one of those class examples? Yeah, class A. I'll call this class the ABC class. And inside there is private int A, int B, int A and B. That's fine. Now let's try function public, I guess. Let's write a function. It will return an integer and I'll call the function C and its parameters are going to be A and B. Wait a minute. I forget. How do I write multiple functions? I forgot how to write multiple functions. Sorry, multiple parameters on one function. Like this, int. Oh wait, it should be void. I made a mistake. It should be void here because I don't need parameters. Do I even need this? I don't need this. Private is blank. Or maybe I should make the whole thing, whatever, it doesn't matter. Okay, we have this. Hang on, I need to check something real quick. Can I define the void somewhere else? Can I define the functions somewhere else? Yeah, I can just define the functions right here. I don't need to do it this way. Yeah, I think I can do something like this. int A, int B, declare these. Hold on, I've got a better idea. int A, B, and over here I will do this. int C underscore C. This is my int, which is an integer. Then C underscore C equals to A plus B. Wait, why am I making this too complicated? I can just do this. Return C underscore C. This is my function. And now let's do it. Int main. Let me run this function. Let me call this function now. Hold on. Yeah, that's how you call the function, I guess. What's the class name again? CQ. And over here, the function name is not here, here. The function name is ABC. ABC dot C. Right? This is how you do it, right? I may have made a mistake, but it's fine. It should be fine. I called this function. It's going to return something. So int d equals to this. Then this is output, right? All right, I have to write something. C out. This is the output. D. Let's see if this works. Expected an initializer before D. Oh, right, I forgot this. Wrong thing. I'll take a look at that later. I'm not sure what that was about. Did I accidentally get a virus somehow, or was my code so shitty that Windows Defender thought it was a virus? Hold on. What's this error? Expecting primary expression before this. Did I mess up something really badly? How did I do it here? Hang on. Class CQ. Wait. Did I accidentally put everything in public? I mean private. Maybe like this. Hold on. I need to look this up. Give me a sec. Okay, so I was being dumb. I figured out what was wrong. My brain, because I haven't done any C++ in a good while, in like a month, my brain kind of reverted into Python mode, I guess. Is it Python mode or is it something else? Whatever. Either way, I forgot that I had to declare the class that I'm using. So yeah, this works. 2 plus 3 does equal 5. There. Now, let's see what happens if I do this. Save. Still 5. Okay. So we learned, what did we learn here? For functions, this and this is the same. Let's carry on. Now where were we? Another subtle difference between C and C++ is that in a C++ program, All functions must be prototyped. Remember, in C, prototypes are recommended but technically optional. In C++, they are required. As the examples from the previous sections show, a member's functions prototype contained in a class also serves as its general prototype. A member functions prototype contained in a class also serves as a general prototype, and no other separate prototype is required. A third difference between C and C++ is that in C++, if a function is declared as returning a value, it must return a value. Okay. You must explicitly declare the return type of all functions. One other difference between C and C++ that you will commonly encounter in C++ programs, you will commonly encounter in C++ programs has to do with where local variables can be declared. In C, local variables can be declared only at the start of a block prior to any action statements. In C++, local variables can be declared anywhere. Oh, one advantage of this approach is that local variables can be declared close to where they are first used, thus helping to prevent unwanted side effects. Finally, C++ defines the bool data type, which is used to store Boolean values. C++ also defines the keywords true and false, which are the only values that a value of type bool can have. All conditional statements must evaluate to a bool value. In C++, any non-zero value, hold on, any non-zero value is automatically converted into true, and any zero value is automatically converted into false when used in a Boolean expression. The reverse also occurs. True is converted to 1 and false is converted to 0 when a bool value is used in an integer expression. Okay, let's check some examples. Okay, introducing function overloading. Now this is something I kind of know what it is, but I'm not too well versed in. So I'm excited to read this part. The next section. After classes, perhaps the next most important and pervasive C++ feature is known as function overloading. Not only does function overloading provide the mechanism by which C++ achieves one type of polymorphism, it also forms the basis by which C++ programming environment can be dynamically extended. Because of the importance of overloading, a brief introduction is given here. Okay. In C++, two or more functions can share the same name as long as either the type of their arguments differs or the number of their arguments differs, or both. When two or more functions share the same name, they are said to be overloaded. Overloaded functions can help reduce complexity of a program by allowing related operations to be referred to by the same name. Okay, I think I understand this. Let me write this example out. Let me just test this out by myself. So first, I am going to define a few functions. Int let's do a simple addition thing. Yeah. Int add. Int add is so int a int b. Define the function a plus b. Int c. C equals to A plus B. Return C. Okay. Then I'm just gonna do another one, which is float AD. Float A, float B. Define it. Define the function. Float C. C equals to A plus B. Return C. Okay, let's see now. Empty main void. First in. I forgot something. Forgot how to do inputs, which is really bad. But it's fine. Just a quick reading should be more than enough. Okay. A, B. I should declare this. Int A hold on for a sec. I don't think I need to do this thing. Instead, I can probably do something like this. Add equals to 2 and 5. It is going to return something. So why don't I do something like this? This should work. Return 0. Right, I forgot this thing again. God damn it. Did I really forget to put the semicolons on both? This is definitely because it's triggering, because my shitty code is what's triggering this. 7. Oh yeah, 2 and 5, 7. Yeah, this Windows Defender thing, for whatever reason, my own shitty code seems to be triggering it. Now let's do something easy. 1.5 plus 1.5. This should be 3.5. Better yet, 2.25 plus 2.25. 3.25. This should be 5.50. And it should return float. All of, wait, do I need to do double instead of float? Let's try it. I need to read up on that a bit. Why 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 is this double and not float? Yeah, you can stop that now. God damn it. How do I turn this off? I'll look into it later. But yeah, it's working. And I do believe, I 100% believe that this thing is because of my code, because it's trying to run, it's identifying my own shitty C++ code as a potential virus. Because last I checked, I did not have any weird viruses or whatever on my computer. I don't know why Windows Defender suddenly thinks my code is a virus. Maybe because of the recent update, Windows update I gave it. That's my best guess. But yeah. Anyway, that's how we do function overloading. It worked. So where was I? Let's continue reading this. I am gonna read the examples on my end, even if I don't do all of them. It's important to understand that the return type alone is not a sufficient difference to allow function overloading. If two functions differ only in the type of data they return, the compiler will not always be able to select the proper one to call. Okay, here's something. The next section. C++ keywords. C++ supports all the keywords defined by C and adds 30 of its own. The entire set of keywords defined by C++ is shown in table 1.1 Also, early versions of C++ defined the overload keyword, but it is now obsolete. Where is table 1.1? It's table 1-2. I don't remember the table 1-1. Did I miss it somewhere? Yeah, I don't see the table 1-1 the book is referring to. Wait, did I skip a page or something by accident? The frick? Yeah, there is no table 1-1. Maybe it's in the next page. Okay, time for the next chapter. I'm introducing classes. How long have I been recording? I need to check that. 41 minutes. Let's keep going a bit longer. This chapter introduces classes and objects. Okay. Constructor and destructor functions. The first topic. If you have been writing programs for very long, you know that it is common for parts of a program to require initialization. The need for initialization is even more common when you are working with objects. A class's constructor is called each time an object of that class is created. Okay, thus any initialization that need to be performed on an object can be done automatically by the constructor function. A constructor function has the same name as the class of which it is a part and has no return type. There's a short class that contains a constructor function. Ah, it is important to understand that in C++, the variable declaration statement is an action statement. When you are programming in C, it is easy to think of declaration statements as simply establishing variables. However, in C++, because an object might have a constructor, a variable declaration statement may, in fact, cause a considerable number of actions to occur. Having a constructor or destructor perform actions not directly related to the initialization or orderly destruction of an object makes for very poor programming style and should be avoided. Okay. I want to try something. I am going to. I understand what constructors and destructors are now, but I want to try something real quick. And I'm going back to a previous example because I'm going to build off of that. Class ABC. Alright. Int A. Now for the public stuff. So this is the constructor. Int A. Let me define this function right here, right now. Never mind. A equals to B. Then here's a different function. Void store. Cout A. Let's see if this does anything. Now int main void. No parameters. My class is ABC. I will declare it as x. Now x dot show. So and return 0. So if I wrote this program correctly, this line right here should do this, which is the constructor. This is the constructor. Hold on. I forgot that it takes an integer. So 5. So what if I wrote this correctly, what's supposed to happen here is when I declared it, it's supposed to run the constructor which takes the 5 and puts it here, I guess, into A, and then it should show 5. Somehow I think I'm gonna get an error, but let's see anyway. I did not get an error. I doubted myself a lot, but in the end I actually wrote the code right. Okay, Windows security, you can shut up. Yeah, I wrote the code right. Again, I doubted myself heavily, but I got it right. And I actually got ahead of myself because I just flipped to the next section of the book. It's constructors that take parameters. Let's see if I did it right and by reading this part. It is possible to pass arguments to a constructor function. To allow this, simply add the appropriate parameters to the constructor function's declaration and definition. Then when you declare an object, specify the arguments. To see how this is accomplished, let's begin with the short example I've shown here. Blah, blah, blah. Yeah. Int A, public, int X, the constructor. Yeah. The example in the book is pretty much exactly how I did it. It is exactly how I did it. So somehow I got ahead of myself and actually did the next part. How long have I been recording this? Almost an hour. I think this is a good place to call it because the next section, I just skip to the next section and it's introducing inheritance, and somehow I think I wanna tackle that in its own fresh episode. So for now I am gonna pause and then I'm gonna play some chess. I have been on a losing streak in chess lately, so hopefully I do well, because I tend to do a lot better at chess when I'm actually playing it on camera, mainly because I'm not distracted by my own thoughts or something else I'm listening to in the background, and instead I'm actually thinking every move through. So yeah, I will see you in the chess match. Okay, so I am over here. Let's find a new opponent. Oh, a 550 rated. This is gonna be an easy match then, I guess. But I should still give it my all because recently I lost to a 300. So should not underestimate anyone. I'm just gonna take it. I am playing the very shitty Duras Gambit. So if the queen comes here, I can do this. And I need to block this before I do anything else. This is gonna come sooner or later. Okay, maybe not. Move it here. Targeting this one. So I should protect that. I don't want to move this here right now because that will block my bishop. So I guess I'll just move my knight here instead. Yeah. I guess I could have done it like this. Takes. Then I could have taken this. So I guess that was a mistake on my part. But maybe I can still recover from this. Takes. Hold on. I thought that wrong. I thought takes, and then I do this, but I would not be here. I would be over here. So that was me just thinking about things that don't work. But now I can take this and then I can attack. So even though my calculation was wrong, I somehow I outsmarted my own bad calculation and ended up doing something good. So that's funky. Anyway, I am going to do this. Check. If this, then this. And if this, then this. But if this... I just realized something. I made another mistake because if he had done this, then... No, I could have done this. And that would have been a fork. But I would have still lost my knight eventually. Anyway, no point in thinking about that too much now. This. If this, then I take. So you're not going to do this. I know that much. Hang on. If I remove my knight, I get a discovered check on you. Oh, you're trying to take my knight actually. So if I get a discovered check on you, can I place my knight somewhere where I can take something brutal? Well, I can always take this. And I do need to get my knight to safety, so... Yeah, let's take this bishop. But... if the bishop moves there and attacks my queen, that's fine because then I can just move here and take this pawn. But then I guess... I don't know. Then I guess he'll have to do something. I don't see any way he can attack my queen. Okay, so you defended my bishop. I am going to do this. I am targeting this one. Both to attack the queen and also to take this pawn. Never mind. I think you want to go here, right? Why did you bring that queen down? What are you targeting? You're attacking this and this. You can move here. Whatever. I'm just gonna do this. Defend both at once. Next I'm gonna do this and you're gonna lose a rook. Unless you move here right now. But I don't know if moving there is a good move. It probably isn't. You're still losing this pawn right here. I feel like moving the rook over there by itself was a bad move. I mean, I can block this check with the bishop. I don't... Oh, no. This is protected. That was not protected. Somehow I missed that completely. But that's fine because you took one of my pawns. But everything else is kind of protected. So I think we're chilling. Plus I can do this. Oh. Holy shit! That was a huge blunder. That was a huge blunder. I blundered my queen. And he resigned. He just realized the massive blunder. Like, look at this. Look at this. So, this is the evaluation. I am chilling. I'm chilling. Then, you do this. I do this and the evaluation should drop. Why isn't the evaluation dropping? It's like a full... Why didn't the evaluation drop? Hello? Oh, this is a check. If I just blunder my queen like this, does my evaluation drop? No, for whatever reason, they are not dropping the... Oh, that's why. Because I have taken so many pawns and pieces that even after I lose my full queen, I am still up 1 point in material. I would not have been able to convert this position. I'll tell you that much right now. I would not have been able to convert this position. But I'm getting distracted. So guys, that's it for this video. If you like this video, be sure to leave a like, comment and or subscribe. Dislike it if you hated it. I'll hide your comment to let you know I've read them. So just because I hated your comment doesn't mean I agree with it or endorse it. I'm Zulk-BS and I'll see you next time. Goodbye.